Today we're going to look at more examples of finite geometric series. What I want you guys to keep in mind is that to find the sum of any series, you can either, one, use the addition method. Okay, so this is the best method if there really aren't a lot of terms, and I would just use your calculator. The other option is to use the series formula, and this is best if the n is kind of a higher number, or if the numbers that they give you aren't so nice looking. So excuse my second grade handwriting here, but this is the formula to find the sum of the first n terms. All right, let's look. So on this one, I've got the geometric series, and it has 7 terms. So for you, you might be like, well, 7 terms is a lot of terms, and others might say, 7's not that bad. So I'm just going to go with the addition series because I don't think 7's too bad of a number. So let's see. So this is going to be our n. All right, so then the first term is 1,000. Now keep in mind that if they are successively decreasing something by 20%, that means it is only 80% of its previous amount. So when they say that it is decreasing by 20%, the r is actually 80%. And 80% as a decimal is 0.80. So when they say let's write down our series is going to start off at 1,000. And then I'm going to take 80% of that. So grab your calculators. You're going to take 1,000 times 80%, so 0.8 or 80, and you get 800. So that's the second term. And then I can keep doing this 7 times. If you're like, that's too much, then maybe you use the formula instead. So I'm going to take that times 8, or 80%, and so that gives me 640. Take that times 80%, you're going to get 512. Take that times 80%, we get 409.6. Keep going, times 0.8, so now we're at 327.68. 1, 2, 3, 4, 5, 6. So I got to do one more. There we go. So I get 262.144. So there's the series if I write it out. And so now if I want to find the sum, grab your calculator and add all that stuff up. So take 1,000 plus 800 plus 640 plus 512 plus 409.6 plus 327.68 plus 262.144. So we get 3,951.424, and HRW will tell you how to round. All right, let's look at this one. So the first term, so the A, is negative 12. The last term, okay, so we're going to stop when we hit negative 972. And they are trickling, so my r is times 3. So take that times 3, and we're going to get negative 36. Take that times 3, we're going to get negative 108. Take that times 3, we're going to get negative 324. Keep going, take that times 3, we're going to get that negative 972. Okay, so there's my series. And again, if I want to find the sum, I can either use the formula or I can just type that into my calculator. And that's not really a lot to type in. So negative 12 minus 36 minus 108 minus 324 minus 972 gives me negative 1,452. All right, let's look at the next one. So we've got a chess tournament, and it's held in London in 1851. It's a single elimination tournament in which the paired competitors play matches, and only the winner of the match continues on to the next round. So we have 16 competitors. Okay. But per game, there's 2 players, or 2 competitors, I should say. Okay, so then that tells me that in the first round, there are 8 games. Okay. Or you could make a table if you wanted to. So the first time there is 8. Okay, so then only one winner from the match is going to move on. So only one of the two will advance. So the R is 1/2. Okay, so take this times 1/2. So second round, then there's only 4 games happening. Third round, then there's only 2, so take that times 1/2. Fourth round, take that times 1/2. There's only 1 game, and then in that 1 game, there will be a final winner. So it says how many matches were played. So what's the sum of those first 4 rounds? Well, there were 8 games. Then there were 4 games, then there were 2 games, then there was 1 game, so total there were 15 matches. All right, let's look at this next one. So we have a ball that's being dropped and it's allowed to bounce repeatedly. And so on the first bounce, when the first bounce is going up and down, the ball reaches a height of 32. So as the ball goes up, it goes up 32 inches, and then as it falls. So on the first bounce, it traveled up and down 64 inches, okay? And then it says on each successive bounce, it's only 75%. So the rate, or the ratio, is 75%. Okay, so remember 75% is 0.75. So I'm going to take that times 0.75. All right, so I could keep doing that 10 times, but 10 is kind of a big number for me, and I don't want to expand that out 10 times. So I'm going to use the summation. So we're going to find the sum of the first 10 terms equals the first term, so 64, and then we're going to say 1 minus our R, so our 0.75 to the 10th, over 1 minus that 0.75. Okay, so as I type this in, I'm going to type in my numerator to the 10th, and then I'm going to divide that by, this would be 1/4, and then I'm going to take that times 64. I was just looking at my final answer. I mistyped something, so I'm just going to type it in again. So 1 minus the 0.75 to the 10th. And I'm going to divide that by 1 minus the 0.75. And I'm going to take that times 64. Yeah. Okay, so that's about 241.6 inches after 10 bounces. Okay, let's look at the next one. All right, so on the first bounce, we have 16 the first week, 56 the second week. Okay, that's really all I need. Okay, so I know that's my first term. My R is 56 over 16. So divide those both by 8, so we get 7 halves is our common ratio. So it says, what's going to be the total number of cases after the 5th week? So honestly, this isn't really that big. I could keep doing this up to 5. Okay, so that's not too bad. So we're going to take 56 times 7 halves. Okay, so we get 196. We're going to take that times 7 halves. 686 times 7 halves. And so we get 2,000. So what is the sum of the first 5? So 16 plus 56 plus 196 plus 686 plus 2401. So I get 3,355. Okay. Your other option, or you could have used the sum formula. And you could have said, okay, well, I know that it's going to be 16, and then it's going to be 1 minus the 7 halves after 5. Okay, type that into your calculator, and you're going to get the same answer. So it just depends on which method you guys like better. So then it wants to know, well, how many weeks is it going to take for the total? Okay, so when is this total going to be over 40,000? Okay, so if I take that 16 times 1 minus 7 halves to the n, I want to know when is this going to make that over 40,000? So when is it going to exceed? Means when is that going to be greater than 40,000? Okay, so I want to clean this up a little bit. So I'm going to divide both sides by 16. So 40,000 divided by 16, that's going to give us 2,500. So I'm going to say 1 minus that 7 halves to the n. I'm going to go ahead and do 1 minus the 7 halves as well. So 1 minus 7 halves gives me negative 2.5. And I want that to be greater than, this is 2,500. I'm going to go ahead and clean this up. Instead of dividing by negative 2.5, I'm going to multiply both sides by negative 2.5. Okay, so that's going to cancel with that. So I get 1 minus, we're going to say 7 halves to the n greater than or equal to, that's going to give me negative 6,250. I'm going to subtract the 1 over. So I get negative 7 halves. N greater than or equal to, that's going to give me negative 6,251. I'm going to divide both sides by a negative. So I want to see when is 7 halves to the n going to be greater than or equal to 6,251. So grab your calculator, 7 halves, and start taking it to some exponent. I'm going to just plug in a 4 and just try that out. So that is not greater than 6,251. Okay, so I'm going to backspace. Let's try 8. Okay, so that's definitely higher, but let's try something smaller. 7, that's bigger. Okay, but if I plug in a 6, that's under, so the n would have to be 7. All right, let's look at our last example. All right, so you've got a person who's depositing $5,000 into an account. Okay, so that's their start. Okay, if the account is earning 4%, we'll figure that out. And then for 10 years, so the R and then the N is 10. So if you are adding 4% to your account, okay, so for example, if I had $10, okay, and I want to add 4%, then I'm going to have to say 10 plus 4% of 10. And if I undistributed that, if I pulled out a 10, that would be 1 plus the 0.04, which is 1.04. So our rate is increasing by 4%, so 1.04. All right, and then what does the future value hold after the 10th deposit? So after you've done 10 deposits, what's your total amount? I don't feel like doing something out 10 times, so I'm going to use the sum formula. I'm going to say the sum of the first 10 terms, or 10 deposits. We're starting off with 5,000. We're contributing 1.04% after 10 payments. And then we're going to say 1. I made a mistake. I need to put a minus instead of a plus from our formula. So 1 minus, there we go. And then we're going to say 1 minus our 1.04. Okay, grab your calculators. Type in 1 minus 1.04 to the 10th. Hit equals. Say divided by, put parenthesis, 1 minus 1.04, and then take that times 5,000. Okay, so after 10 deposits, the person's going to have 60,030 and 54 cents.